Welcome to Total Network Operations, the project with a podcast that's dedicated to hardworking network operators like you who deliver all the packets. Here on Teen Ops, we shine a bright light on great ideas in NetOps so you can make informed decisions for your network and your team. I'm your host, Scott Robon. Today, we have a sponsored episode with Juniper Networks and Abhi Shamsundar, Director of Product Line Management for Juniper Mist and Juniper Mist Wired Assurance. Abhi, it's great to have you here on Teen Ops today. Tell us about yourself, a little bit of your history, and what you do at Juniper Networks.
Thank you so much, Scott. My name is Abhi Shamsundar. I'm a part of the product management team at Juniper Networks. I've been at Juniper Networks since the inception of when we moved as a part of the Mist conversation into the Juniper world. This happened in 2019. I was a part of Mist prior to that as well. Mist as a company focused heavily on wireless when we began, but the company essence of the company was always about operations. AI ops was a term that was coined initially around that time, and how are we able to do things that a human would do in an automated fashion, and that's where AI ops came about. A lot of the hardware that was shipping was the access points at that given point in time. Mist as a company was founded in 2014, and the essence of Mist around that point of time was how we are able to gather telemetry from access points, make intelligent decisions, and build a phenomenal cloud for us to do, what we typically call as day zero, day one, and day two. Day zero, provisioning devices, being able to do zero-touch provisioning, ease of use from the customer perspective. Automation is at the heart of all of these three conversations, day zero, day one, and day two. Create flexible templatization for us to deploy that. But the heart of it was all where the cloud came into picture was day two. Being able to collect telemetry, every user, every minute, all the way up to the cloud, crunch numbers, and not just tell them that, hey, there is a CRC error in here, rather talk about the outcomes of saying there's a bad cable because we've seen incrementing CRC errors over a period of time, was kind of the notion of, where we, how, the Mist and its inception was all about. Subsequently, post, the acquisition with Juniper Networks, we've been able to expand this to the portfolio just beyond access points. If you look at enterprise networks, there's access switches, access points, then there's distribution switches, core switches. So we've spread our wings all across, and now it's going beyond that. We are doing data center, WAN routers, and MXs. So it's been a phenomenal ride overall for us.
How challenging has it been taking Mist control plane, automation, and AI ops? It's starting being very focused on Wi-Fi, and now applying it to other network domains. What are some of the things you've had to overcome as you start to look at wired access switching, core switching, even on the very big router side, like the MX that you just mentioned?
Yeah, the heart of all of this, like how Bob Friday would describe this, we need good grapes to make good wine. The heart
just made me really thirsty. You just made me very thirsty.
Yeah. For us to make the wine that we're intending to make, we need really good data. There are a couple of things that are important for data. The freshness of data, how soon, how quick can we get that? And also the data that comes in should be of good quality and not quantity, because you're riding on top of customers' WAN for us to get that information. Granted, the cloud will do all the crunching and get you the outcomes of it, but you wouldn't want to be a burden on the customer's network as well. So the smarts of being able to get data quickly and also data exactly what you need and not the entire blob of a JSON is critical. So that's why you would see protobuf and all of these fun ways of gathering information becomes very critical. To your question on how difficult was it, the beauty of the solution or the marriage that happened between Juniper and Mist was that Junos was highly automatable for both provisioning as well as us to gather telemetry. If you see, they've been at the forefront of sensor-based telemetry even before it was us. gRPC sensors, being able to gather telemetry. For us, it was all about packaging this information and sending up to the cloud, which was not the hard part because we're very good at doing this and we've been doing it a long time before that. So I think to your question, Junos became the heart and soul of us because it was so automatable. I'll give you an example. The switches and the routers have a function called as commit confirmed. What it does essentially is you can present your intent, and if you do not actually confirm the intent, it'll roll back to its previous configuration. That's automation at its best. What we did on the Mist UI, we called it differently. We called it a revert timer because you're going to be a cloud managed switch. Every commit for us would be a commit confirmed. What that does to you is if you, let's say, put in a wrong IP address on your subnet or the wrong subnet mask to say instead of 254, you did 252. Whatever the reason could be that could kick the connection out, or your default gateway was wrong. We will roll back automatically. We promise you will never ever leave a cloud managed switch stranded for you to go have somebody run into do a truck roll for you to bring that switch back up. So that's an example.
Always have that lifeline to the network element. Very good. Yep.
Those are some smarts that is an example as to how Junos and Juniper was made very, very well, very automatable, very easy to gather telemetry, package that. And that's why you'd see extremely seamless integration of, we did the access switches. And then when I took on the role for doing wired stuff, for me, it was a very easy integration to start doing access and distribution switches as a portfolio to be built out. And that's the portfolio, wired assurance as a whole.
Very good. So you probably started out getting select data elements via access points at your start. And have you expanded to collecting, like what sorts of data are you collecting from APs versus wired Ethernet switches and more? What are you sending up to the cloud that's actually being crunched?
So if you see the dashboard, the very first landing page of our dashboard points to a page called as the SLEs, which is the service level experiences page. And the way, and every time I talk about it, the way the page is structured is for you to know the health of your network from a client's perspective. That's the most critical part. It's not about the device being up, device being down. Is the client able to function? And you start to think about, the problems that plague your network. They can be broadly classified into just two problems. Either the client can connect to the network, or the client is connected, but it's having a poor experience. Everything, if all else is the same, these are just the two problems the client will always have. Now, how do you, as a professional, break this down further and give answers of, what happened to pre-connection, what happened to post-connection is all the data that you would want to bring to the cloud. So the pre-connection, what are the steps that a client goes through to connect to the network? It has to go through, if it's a wireless client, you have to go through association. If you're a wired client, you got to go through authorization, authentication, grab an IP address, ARP for your default gateway, search for a DNS success, and then off you go. This is, basic 5 steps that you always look at.
Yep.
How are you able to go tell or create telemetry for each of these functions is what was critical. So to your question on what kind of data that you would bring into the cloud is about just breaking these pieces down to say, was the association okay? If not, on the wireless side, we create a packet capture dynamically for you at the point. So if there's a bad event, we qualify things as all the different events as good, neutral, and bad. And for bad events where you would actually be able to, because especially in a wireless world, it's a lot more harder to ask the person to go walk the exact same hallway that they walked when they had a poor experience. So the idea behind, packet captures being dynamically done at that point in time, Mist was the only company that did that. And So that was very critical as part of one of the data that would come to the cloud. So you can easily click on the packet capture download and say, oh, this is it's failing during authentication phase at this point in time. Same constructs appear for the wire, and on the wireless world, there's post connection to your roaming, your capacity. You're connected to an AP which has 16 other clients connected, and all, or it's just one other client who's watching two 4K streams at the same time. Whatever the use case is covered under this SAT. We started with the same two problems for the wired network as well: pre-connection, post-connection. Think about all things that could go wrong on a wired network. And we again start with the OSI model. Layer one, there are signatures on the switch for us to tell where the problems at any given point in time. So you can use these signatures and then bring about, if there's a bad cable, bad optic, for example, transceiver, SFP, then you go into layer two. You talk about MTU, negotiation, all of this stuff. Then you go into layer three. So you grab all of this telemetry, error counters, and then make meaning out of it. Use these signatures that are available as sensor telemetry. You bring it to the cloud, and then you look at a baseline of a particular error value, and then a deviation in the baseline. If something is continuously incrementing, you want to know about it. You want to let customer to know about it. So, and also what these error counters mean. Some of them are just three-letter jargons. Some of them may not understand. How do you write this out as an SLE, or even we call this Marvis actions in the MIST world, to say, we know your cable number, your port number 1033 on switch 1 has a bad cable because we've done all the number crunching, but the data was directly natively from the Junos that was sent as a telemetry sensor.
So this is really more than what we would classify as typical telemetry. Like, you're capturing very basic call flow type information of a device connecting to the network, whether it's via wireless and the association process to the AP, or just plugging in and seeing what does it take for me to get an IP address via DHCP. You're capturing all that. You're sending all that data up to the cloud. Very good.
Yeah, and in fact, since we learned so much from the wireless world, our newer versions of code now also do dynamic packet captures upon port up, because the first 50 or 70 packets that you flow define whether you were successfully able to onboard or
Sure.
where it is going to. So now on the wired world too, you have a dynamic packet capture for us to gather and go from there. So one of the things that you would see when you speak with product management from Juniper MIST, something that's very consistent all along is most of us, or almost everybody, have their ears close to the ground. When I say that, we are a part of a deployment, regardless of what your title is. We have certain customers that we work with. We go and do cutovers in the night with them, learn exactly what the problems are. And that's why some of the use cases that we speak about are all directly from looking at a problem that we faced, and we come back and say, what did we learn as part of this cutover? Obviously, you want to make it successful, but if there are things that we can do better, we learn and we implement in the product. So you would see that in majority of the people you would speak to with MIST.
Very good. Well, let's focus on wired assurance and the impact on the operator. How does this make a network operator's job easier? I want the answer to be yes. Of course, it makes the operator's job easier, but tell me how.
Yeah, so we spoke about telemetry that comes to the cloud. And for us, all of that needed to become an outcome for us to drive towards saying, if somebody is buying a switch, and if somebody has to invest more money on top to buy software, it has to be something that's useful for them, and they also have to justify those costs for them. Well, a few things that you would hear consistently. Obviously, it's my baby. I will say it's the best product in the world, but you would see,
no bias at all.
No bias at all. But the few things that you would see, if you look at reviews, Gartner reviews of sorts, you would see that things work with Juniper Mist. Things just work. And what do we do behind the scenes to make things just work? Or if they aren't working, what are things that we go about doing and enabling the operator as a whole? Is, for us, the heart of it is to be able to say, get an overarching picture, start with an org level SLE view to say, how is your network doing? If you're a network operator running 200 sites, or or even 5,000 sites, which all of these are real life examples that I'm talking about, and you want to be able to say, what are the areas that I need to focus on? You have a bird's eye view of the org level, service level experiences. This always talks about, whether your pre-connection is okay, post-connection is okay. And we also monitor, obviously, device level metrics. For us, for example, we spoke about bad cables. We also look at congestion as a whole. Now, traditionally, you would have said, oh, these are called tail drops. But tail drops are just another word for you to say somebody is pummeling my interface with so much traffic that I can't handle it anymore. I've queued enough, but no amount of queuing is stopping this packet, so I need to start dropping traffic. That's called tail drop. But what is it generally in a language that you and me understand? It would be called congestion. So we call it congestion. Then you look at congestion of the uplink, because we want to define if there's one bad actor just pummeling traffic, that's okay. But if it's the uplink that's congested, you don't want the entire floor to be affected because of that. You want to see. So the idea behind operators' life becoming easy is to bring out these indicators that will affect the end client eventually. If the client is the other part that SLEs as a whole does very well is the idea of the scope of the problem. Now, if there is one client that is failing authentication, you're connected to a Radius server. It could be our own cloud-based NAC. It could be any other third-party Radius server, or even free Radius for that fact. If a device is failing connections, you want to be able to quickly know if it's just few devices in your network, or is it the Radius server at lunch?
Sure.
So that kind of scope analysis is done by the SLE framework. It's not a bunch of tables, but it also gives you scope analysis and mutual information. And that's where all the AI starts coming in. But AI, at the end of the day, is driven by outcomes that it can drive for us. Instead of me telling you, we use mutual information, we use reinforcement learning. That's all great, but what does it mean to the customer? Are the outcomes that I drive towards to it? Say, hey, there is congestion on this. Go check what is this device? Why is it doing this? There's congestion on the uplink. Is there a capacity planning that we need to change? Your access devices are running hot. When I say that you're running a layer 2 network, your MAC tables are coming to being full, and that's not a good situation to be. We need to figure out, we need to tunnel. Do we need a different design for your wireless networks, or do we just need to figure out why your CAM tables are full? Whatever the reasons are, you're not looking for imagine you having to go through every single interface of your network and having to scrub through every single error counter or every single event that has happened on the switch. Or rather, I could bring about exactly those needles in the haystack into one page and tell you these are areas that we would want to pay attention to. And that's how we make operators' life better. A couple of other examples I spoke to you about, we going up the stack, right? We said layer 1, layer 2, layer 3. We also started modeling against traffic patterns. Every network engineer's favorite packet types, multicast and broadcast. If they are in in a place where it's not deviating too much from the baseline, or not, there's some sense of normalcy, that's great. The moment they trigger and go off to insane numbers, you'd want to know. And usually there are only 3 or 4 reasons for it to go, for a well-operating network to start seeing deviation in baseline. Somebody added a new switch, some config change was made, a new port came up at this exact same time when when our anomaly detection started freaking out, whatever the answer is. But the point was to say, and this happened as an example at a large hospital. We said, hey, they said the network's not doing so well. Actually, their definition, it's network's melting. Usually that's the word that they would use when the complaint comes in. We looked at our Marvis actions. There was a traffic anomaly as a Marvis action at this point in time. And there was correlating events at the same time to say there was this server that was connected. But the idea of, if you had an entire estate and you having a hard time to figure out where exactly things are wrong with, especially, a network melt as a situation, it's just so much more simpler when you have the data and you know when there was a deviation from the baseline and what are some of the correlating events that are present there for you to actually look at it. So, and for us, mean time to innocence is one part, but mean time to resolution is the final goal we are trying to.
Sure.
Maybe we are not even the culprit for this situation. So mean time to innocence becomes an important point. How quickly can you get to that part is the answer that we are looking at. And that's an example of, look constantly, and we look at every single port every minute, and we look for deviation from baseline, and that's powerful. And for you to do anything to this, extent, I think you would need a cloud. Nothing on-prem can do this kind of number crunching for us to be able to scale. Whether you are, 3 stores or you want to expand to 3,000 stores, whether you're a small campus that is trying out Juniper Mist day one and you want to expand to 1,500 switches in the same campus eventually, you don't have to worry about it. The cloud grows with you. And that's the agility that brings along, that makes the operator's life easy. It's a single console, single dashboard.
And that expandability as you grow, that's built into the Mist offering, correct? Like I don't need to go order separate supporting, cloud services. It's all built into what Mist does. So that automatic scale out happens as you grow from a number of branches perspective in your previous example.
Absolutely. There's not a requirement for you to have additional licenses, nor do you have to let us know that you're expanding. We know in the cloud auto scales based on your requirements. So absolutely built in. Yeah. For us to make this easier for the customers.
Now, I'm persuaded about the computational capability, right? You need to crunch that volume of data somewhere where there is compute available to do so. But what would you say to the person who has concern about, well, wow, I'm sending a lot of data off-site, either from a volume perspective, like that's taking up capacity on my links out of the facility, and a security perspective? What do you do to address those two issues?
In fact, you think about, the largest of banks, you think about the largest of retailers, all of them come from a security conscious world.
Sure.
And so let me address the first question first. Because of how we use protobuf, and we also use efficient ways for us to just push data that is required and not just a whole chunk of data. It's every user, every port, but exactly the values that we require. That's extremely small. And that's why you would never see us, tanking any WAN network. And that's why nobody even thinks about this when you're running a cloud managed network, because we have to be conscious of how we do that. And that is very well aligned in terms of utilizing modern technologies, efficient ways of using protobuf to send information to the cloud. The second part, one of the things that you would see when you start asking questions, even before, hey, why you cloud manage? Do you use Office 365? If the answer is yes, you're already in the cloud.
Right. Sure. Or Google services, or you name it, right?
You name it. And everybody's in the cloud. Your data is in the cloud. And the cloud is protected by various different certifications that actually operationalize or SOC, ISO, you name it, and we go through a ton of pen tests to make sure data at rest, data in flow, everything is encrypted, everything is segregated. There's a bunch of things that happen in the cloud to make sure, and this is all provided to the person who's asking this question as well. And that's why you would see, the largest of banks working with us and running large networks with us, because they understand the data that we grab that is required for us to make this telemetry and make all of these functions well is not technically PIR. We're talking about error counters. We're talking about even packet captures you could have on demand. Like, if you're running, click on a port and say, I'd like to capture these packets. You could set, I only want to capture the first 128 bytes. You're not going into the payload at that point in time. You're looking at the header information that is required. So we can be smart about how we utilize the information that comes to the cloud. Obviously, all of the other things notwithstanding, SOC, compliance, pen tests, and the security compliances that go along. These are some things that happens every day on the cloud, and these are questions that we answer to customers on an everyday basis. And it's always usually very smooth sailing with the security teams as well, because everybody wants to know where this is going, and we have and as long as you tell them data at rest, data in flow, all encrypted, segregated in a good place, we take the security very, very seriously. But
you wouldn't have made it this far had you not, right? And see the deployments that you have.
That is true.
So you have wired assurance coming out on the new EX4000. Is that correct? Tell us a little more about what. So this is one of the new EX switch platforms. How is it targeted at? What about wired assurance makes this different?
Yeah, super excited about the EX4000 line. Probably, if you ask me, it is our fastest switch to boot up, but also probably industry's fastest, value tier switch to boot up. It boots, sub 2 minutes or even lesser. It is the quietest switch that we have built with the fans on as well. We take a lot of feedback seriously, and value tier switches are placed in, right below the cashier's desk.
Right.
All of these
all
places,
sorts of weird places. Yep.
And the last thing you want to hear about is, oh, you have 48 ports, let me put a fan on it. And that fan is extremely noisy, and the cash register person is very upset with us. And all of these are critical information that we take into building a switch. So our fastest to boot switch, for us, we consider a boot time to be downtime. You want your boot time to be as low as possible, and that's one of the areas that we worked on, because you're going to be doing upgrades, you're going to be going through scheduled maintenance windows. How short can we get that done? And every minute we save is dollars saved for the customer, and we take that very seriously. It is our it's our brightest, shiniest entry level switch. We are extremely excited about it. As I said, I know switch is a switch, but things that matter to a customer, when you bring that about to the forefront, it becomes extremely critical. You now marry that with wired assurance, along with the NAC cloud that we have. A lot of customers have always had an inkling towards making wired .1x/MAB a reality. But because of the amount of unmanaged devices that they may have, or, on a wireless side, it's either a PSK or a .1x, managed or non-managed, there is set ways for you to get devices on board. On a wired side, you have building management systems, you have new cameras, you have stuff that come along. Now, how do you make this a reality of making every single device that comes into your switch, make it authenticated? And that we could do very seamlessly with the NIST NAC assurance, as well as the switches that we have, and with wired assurance being able to monitor. Obviously, we spoke about how we are able to monitor every pre-connection, but think about just an onboarding workflow where you plug all of your devices in, we learn all the MAC addresses, you take them in one shot and bring it to the same Mist cloud, and then say, now let's turn all the ports into .1x/mab. Now, every single entry point into the network, we already know the device is on. If there is a new device that needs to come on, you now have a rock solid mechanism for you to bring devices on board. So there is zero trust conversation that goes on in every segment of the network.
Sure.
Your zero trust should start closest to where the clients are onboarding. And according to me, from a wireless and wired perspective, we need to make .1x/mab a reality in an easier fashion. How long would you think, if I were to give you the Mist dashboard for you to operate on and say, I'd like to make map reality for one single switch, I could do that in 5 minutes, 6 minutes tops, because it's easy for us to gather this information, put that in there. As unlike, you have to have your own servers to build, and we have taken
Sure.
the day zero operations out of the way. I think those are all what make, wired assurance alongside the ability to do packet captures at lower end switches easily will make operators' life easier. And we're gonna continue on doubling down on. You have telemetry coming in. One of the newest parts that we recently worked on is another problem. We were talking about cameras. They keep going offline. They fall off like flies. If you're running an extremely large network, think of 5,000 stores all across. And how do you know how many cameras are connected? If they break, the first level of operation that every network admin or a camera person would do is open a ticket against the network team and say, can you please bounce this port? So again, it all comes down to baselining this information. There was a camera connected. Look at the seasonality. Things are up always. Can we actually automate that function of bouncing the port for you? And that's what we did, right? You use algorithms to learn a baseline of a network. When does it stop working? And then provide in a way for the customer to be alerted about, hey, this camera went down. I bounced the port. Looks like it has come back. But you may want to know about this. Those are places why, wired assurance alongside our newest switch will make our life, operators' life phenomenal is where I would see it.
Automating those elemental things like bouncing a port, if you know the conditions under which you should do it, you can automate it, collect the data, and that's one less thing that an operator needs to be paying attention to and actually executing on. Understood. Very good. So wired assurance is debuting on the EX4000, correct?
Yeah, wired assurance has been supporting all of our EX portfolio up until now. Okay. And with EX4000, what you would also additionally see is we've now a new program called as CloudX, which is the device is natively connecting to the cloud over port 443 and not utilizing custom ports, and that'll be default on. It'll be a fully thoroughbred cloud native switch, and wired assurance will continue to, alongside every other access and distribution portfolio. We'll also have EX4000 natively support right out of the box for us to go there.
It's amazing to see the transition in the industry from 15 years ago and being a very low level of trust to connecting to cloud resources to now a very high level of dependence. And we're just so used to it. It's really been not that long historically, but here we are, and making use of it, good use of it here. So
I love the way you put it, the high level of dependence, and it is convenience that is coming alongside a part of it, and the adoption rates of how many naked switches, when I say naked, like without any software on top, versus switches that are shipped with software, is just phenomenal. The growth rate it's outstanding. It also speaks to volume on how much of trust that you would earn with the customer when you're fully controlled from the cloud.
Very good. Well, as we round the corner here towards the end of this discussion, anything else interesting that you'd love to tease us with that's coming out from a Mist AI perspective on wireless or wired infrastructure in the next year? No pressure, just like anything we should be looking for.
Yeah, I mean, the most again, if you've seen all of the conversations that I have circled my thoughts around, has always been the client. Uh, Up until recently, we could alert you and say this is the scope of your problem only when actual clients came online, right?
Right.
If the clients came online, you're not able to connect your Radius server, then you realize Radius server is at lunch. But can we do that when the clients are not there? And that's the beauty of what we call as Marvis Minis. Marvis Minis has debuted on the wireless front. Granted, the most things that it is actually looking for is anomalies on the wired network, because it's trying to get out to the external world. But next year our focus will be on wired minis on switches, being able to do an ability for us to tell you at 2 a.m. in the morning that your DHCP server isn't working, as against waiting till 7 a.m. before when the crowd starts to come in. I'm extremely excited for Marvis Minis as a concept. A lot more dynamic PCAP abilities, being able to create a packet captures at the point when there is a failure is extremely exciting. We've done it in the wireless world. Doing it right in the wired world as well is something that's extremely exciting. So you would see us invest a lot of energies into that segment as well.
Got it. Well, we'll certainly be looking for that. Before we wrap up, one of the things I like to do with network operators on the program is to ask them about the worst outage they've ever caused. Now, I don't know if that's fair for you, but do you have any good stories about like bad outages where you've seen Mist AI or other Juniper products really help a customer out of an outage situation?
I'll talk about a situation where, let me start, an embarrassing story about when this was way before Mist, and I used to work for TAC primarily, and the only reason this customer called us is they said, I want to add or change the static route and this was a pizza corner, and the pizza place was 2 hours drive. They didn't want to go console in, and they asked if they could do it. We said yes, and before I hit the admin distance where you could actually make it a floating static route,
right,
we hit enter and we lost the switch. And
oh, no.
It was embarrassing. The only reason, I mean, they knew they could drive down there and make this change, and it was so bad. You learn to live another day. It was horrible. Those are times when I remember, and that's why when the moment I got the reins of running wired assurance, well, that scar left. That's why commit confirmed as a story is so powerful. That example was a floating static route example. If you hit enter too early, you're gone. So
you had me at commit confirmed. So as a Juniper TAC engineer 20 years ago, commit confirmed is your friend. I can attest to that, no question. So yeah, I follow you all the way. I'm sure there are others listening who have the same experience.
Yeah. It was it was caused an outage, and then they had to drive in. Not a fun conversation.
Yeah.
You get to learn another day. Yeah.
Well, good for you for drawing into your past and being honest. It's not everybody likes to do that. So well done. Look, if you're in an operations role, it's not a matter of if you're ever going to cause an outage; it's when. And yep.
Yeah.
And there's just a pizza shop, and then there's taking down a global telecommunications carrier. Not that I'm speaking from experience. So, Abhi, it's been great to have you here today. If people have questions, where can people find you? How would you prefer they follow up with you?
2 places: LinkedIn. You could find me at LinkedIn's URL /ABHIRAMMS. And then you could find me on Twitter. Same handle, ABHIRAMMS, followed by a 2. And you'll find me in both places. Happy to have conversations and learn from more of these conversations. Would love to.
I will be sure to go follow you right after this. So very good. It's been a pleasure having you here today, Abhi. Thanks so much. And thank you everyone else for tuning into Total Network Operations. TNOPS is a growing project and we'd love to hear your feedback, especially topics you'd like us to cover and people you'd like to hear. If you know someone or you are someone with important things to say about NetOps, let us know. These episodes provide a channel to promote best practices and big ideas from people like Abhi and Juniper Networks and many others. Spread the word on TNOPS. Let's get other people involved in the conversation. You can drop me a DM on LinkedIn or send us a follow-up at packetpushers.net/follow-up. We'll see you next time on TNOPS.